So in this lesson we're again going to be looking at equations of straight lines, only this time it will be about how we find the equation of a straight line between 2 points when we are given to them within the question as coordinates. It's therefore important that you've watched all the videos on linear graphs to date, particularly the one that focuses on how we find the gradient of a line between 2 points, because we will not have the luxury of having a linear graph to look at today, and again we have to work it out algebraically using this formula. Okay, so we've been asked to find the equation of a straight line that passes through the points 1, 2 and 2, 5, and we don't have an xy axis to plot these points and to look at what this line would actually look like. We must write it in the form y equals mx plus c. So basically we are trying to find the values of m and c, and if you remember in the previous video, m is quite simply the gradient and c is the y-intercept. So m as the gradient is exactly the same as in the previous video where we looked at how we found the gradient between 2 points. We must use this version of the gradient formula. So gradient is equal to y2 minus y1 over x2 minus x1, where the x and y values are found within the coordinates given. Okay, so first thing I'm going to do is I'm going to find m, the gradient, which is y2 minus y1 over x2 minus x1, and I'm going to show what we're substituting in. So the first coordinate was 1, 2, so that is our values of x1 and y1. Our second coordinate was 2, 5, and that is our values of x2 and y2. All right, so we substitute these into the formula above. So y2 is 5, y1 is 2, x2 is 2, and x1 is 1. Okay, so 5 take away 2 is 3, 2 take away 1 is 1, so 3 divided by 1 is 3. So it is a positive gradient of 3, so it would be a line going up the page like that. Okay, so what we have so far is y equals 3x plus c. We still have to find our c value. Okay, I've just substituted m in place of 3, which I found to be the gradient. All right, now the next part is we have to find the y-intercept, and that is done by substituting the x, y values of one of the coordinates, doesn't matter which one, into the equation that we have so far with the gradient included. So I'm going to pick this coordinate 1, 2. Okay, so if I substitute the values of 1, 2 into the equation, and just keeping in mind, of course, with a set of coordinates, the first number is our x coordinate, the second number is our y coordinate. So that's our values of x and y that are going into this equation. So y becomes 2. So I get 2 is equal to 3x. So 3x is 3 times 1, okay, plus c. And this will allow us to find the y-intercept, just solving using a bit of algebra now. Okay, so 2 is equal to 3 times 1, which is 3, plus c. Therefore c is equal to 2 take away 3, which is minus 1. So the final form of this equation, so if I consider y equals mx plus c, I found my value of m earlier to be 3, so y equals 3x, and c is minus 1, so plus minus 1, so we just write that as minus 1, because plus minus is of course a minus. And that is our final answer for this.